Now in this lecture we will be discussing about oxidation states of organic compounds. So generally we are discussing oxidation states of carbon. Now what is the oxidation state of carbon? It's a -2 plus 2. In this lecture we will explain all this. Now to discuss the oxidation state we need one thing to know, that is bond between same kind of atom is called homoatomic bond, and if you have bond between two different kind of atom is called heteroatomic bond. So let us say if I have a bond between carbon-carbon atom, this is a homoatomic bond. If I have a bond between carbon and oxygen, this is a heteroatomic bond. If I have double bond between carbon and carbon, this is again a homoatomic bond. If I have a bond between carbon and nitrogen, this is a heteroatomic bond. Now to find oxidation state of carbon, we have the first rule, that is bonds between homoatoms are equally shared. What is the meaning? So let us say if I have a bond between carbon and carbon, and this bond will be equally shared. That is, this bond has two electrons. One electron will go to this carbon and one electron will go to this carbon. So I will have this plus this. Now let us say if I have carbon-carbon double bond, RDI is same. If I want to break this bond, two electron will go to this carbon and two another electron will go to this carbon. If I have carbon-carbon triple bond, I have to break this bond and three electron will come this side and three electron will come this side. So this is the idea. When you have bonds between homoatoms, it will be equally shared. Now the next rule is bonds between different electronegative atoms is unequally shared. So let us say if I have carbon and oxygen, in this case oxygen is more electronegative. So what will happen? This bond pair will unequally shared and this two electron will basically go to the oxygen side. So if I want to break this bond, what we will have, carbon will get none of the electron and oxygen will get both of the electron. Similarly, if I have carbon and chlorine, chlorine is more electronegative. So if I break this bond, bonds will not be equally shared. Chlorine is more electronegative, so these two electrons will go to the chlorine. So carbon will get no electron and chlorine will get two extra electron. If I have carbon and nitrogen, same idea, nitrogen is more electronegative. Carbon will get none of the electron and nitrogen will get two electron. I can have same idea with carbon and hydrogen. In this case, carbon is more electronegative than hydrogen. So carbon will get two electron and hydrogen will get none of the electron. Similarly, you can have carbon with sulfur. Sulfur is more electronegative than carbon, so carbon will get none of the electron and sulfur will get two electron. So bonds between two different electronegative atoms will be unequally shared. More electronegative atom will get more electrons, that is the shared electron will go to the more electronegative atoms. Now let us discuss oxidation states in alkene. So I have first case, that is CH4. So what is the oxidation state of carbon? So this carbon here. So I am looking for what is the oxidation state of this carbon in CH4 molecule. So let us say we have CH4 and idea is same. We have to break this all bonds, so we have to make free carbon. So carbon atom, so I have to break all the carbon bonds, so we have to basically make free carbon from all bonds. So let us try to free. So if I want to free this bond, what will happen? carbon is more electronegative than hydrogen, so these two electrons will go to the carbon. If I want to make free this one, once again carbon is more electronegative, so these two electrons will come to the carbon. If I try to make free this one, so I will have carbon, 2 electron, because carbon is more electronegative. Same thing I can do. If I free this bond, I will have something like this. Now we have to find formal charge on carbon, and that formal charge is basically equals to oxidation state. So we have to find formal charge, and formal charge in this case is equals to oxidation state or oxidation number. So let us say how we find formal charge. We find formal charge by using, so how many electrons carbon right now have? So actually it has 8 electron, but neutral carbon atom should have only 4 electron. So it has 4 extra electrons, so this means 4 negative charge. So we find formal charge. So we have a formula for formal charge. This is equals to number of electron in neutral atom minus number of electron in actual, that is actual number of electron. So in this case, number of electron in neutral atom, carbon has a 4 electron in neutral atom, and actually it has 8 electrons, so 4 minus 8, so this has minus 4 formal charge, and this is same as oxidation state. So in this case, basically carbon has a oxidation state of minus 4. Now let us say if I have CH3 molecule. Once again you can follow all this idea. One important point we have, this bond will be equally shared. So let us say if I free these 3 hydrogen, we will get 2 electron from each side, because carbon is more electronegative. So if I free these 3 hydrogen, I will get 2 electron, 2 electron, 2 electron. And if I break this bond is between equally shared, because same kind of atom, homo atom, so this will be equally shared. So I will have only 1 electron. So what is the formal charge in this case? Actually it should have, carbon should have 4, but right now it has 7. So basically this is formal charge is minus 3, and this is the oxidation state. So in this case oxidation state is minus 3. So you see, in methane carbon has a oxidation state of minus 4, and ethane carbon has a oxidation state of minus 3. So this point is important. Now let us say propane. What is the oxidation state of carbon in propane? So where we have 3 kind of carbon. So if I free this carbon, so this the leftmost carbon, so I have 3 hydrogens, so we will get 3 electron pair, and there is a bond pair. So if I dissociate this bond pair, equally shared. Now let us say the carbon in the middle, so this middle carbon has 2 hydrogen, so we'll have 2 lone pairs. And now this side bond pair and this side bond pair equally shared, so 1 1. Now let us say this terminal carbon and this terminal carbon is equivalent, so there is no need to find oxidation state of carbon, because this carbon and this carbon is same. Now formal charge for this carbon, we have 2 4 6 7, so 4 minus 7, that is minus 3. So oxidation state is minus 3. For this carbon formal charge is, so we have 2 4 6, 4 minus 6, that is minus 2. So you see, in alkane carbon can have oxidation state of minus 4, oxidation state it can have minus 3, it can have minus 2. Let us see more. In this case, if I see this carbon, so let us say this carbon, because we have already calculated, so I can say if I have carbon 3 hydrogen attached and 1 bond pair, I will have a minus 3 oxidation state. So this is minus 3, this is minus 3. Now let us say for this carbon, So if I am interested in this carbon, what we can do, so we have carbon, we have only one hydrogen, and there are three carbon attached. So this side we have carbon, this side we have carbon, this side we have carbon. Bonds are equally shared, and now we can calculate formal charge. So that is 4 minus 5, that is minus 1. Now you see, in this case, if you see, carbon has basically zero oxidation state because it is connected with this side carbon, this side carbon, this side carbon, this side carbon. So if I do this one, so let us say for this case, for this carbon, I will have carbon this side equally shared, one electron, one electron, one electron, and this side also one electron. So in this case, formal charge is basically 4 minus 4, that is 0. So you see, we have said carbon can have an alkane. So if I have an alkane, carbon can oxidation state of minus 4, minus 3, minus 2, minus 1, and even it can have a oxidation state of 0. So this is minus 1 and this is 0. So minus 1 and 0. So this is minus 1 and 0. So this means function group cannot be assigned on the basis of oxidation number. So we cannot say alkane will always have a fixed function oxidation number. So oxidation number, on the basis of oxidation number we cannot decide the functional group. We will discuss more. Now let us say oxidation states in alkenes. We can have, these are alkenes. So if you see this alkene, all terminal hydrogen, so we have hydrogen. Now if I replace one hydrogen with an alkyl group, we can replace one hydrogen this side with alkyl group. So this one is alkyl group, and now here also we have alkyl group. Now in this case, let us try to find, so if I see these two carbons are basically equivalent, so either I find this carbon or this carbon. This side we have hydrogen, so we will have 2 electron. This side we have hydrogen, 2 electron, and this side we have double bond between carbon and carbon equally shared. So this has 4 electrons, so 2 electron will come to this carbon. Now calculate the formal charge, that is 4 minus 6, because we have 6 actually, so this is minus 2. Now let us say in this case for this carbon, so first see for this carbon. Now we have a hydrogen, so we have 2 electron. Now R is basically alkyl group that is connected by carbon, so this carbon is connected to a carbon, so we'll have 1 electron, and here we have equal division, so we have 2 electron. So we have formal charge, this is equals to 4 minus 5, that is minus 1. And for this type of carbon we have already calculated, so if I have a carbon that is connected by 2 hydrogen and one side double bond, that is same as this carbon or this carbon, that is minus 2. Now let us say this case. Now this carbon, both carbon is equivalent, this carbon and this carbon are equivalent carbon, same kind of carbon. So if I consider this one, I have a hydrogen, so 2 electron, and we have alkyl group, that is basically carbon, so we have 1 electron. Here I have to divide equally, that is 2, so we have formal charge of 4 minus 5, that is minus 1. So once again alkene can have a minus 2, minus 1, even minus 1, and even it can have a 0 oxidation state. Now let us say these are the cases. This alkene if I consider, now for this carbon, this side alkyl group, so we have 1 electron, this side alkyl group, so we will have 1 electron. This bond will be equally divided, so 2 electron. Now formal charge in this case, that is 4 minus 4, that is oxidation state is 0. So formal charge is same as oxidation state, so oxidation state is 0. Now let us say this carbon, this type of carbon we have already calculated. Now let us say this case, so carbon, so let us say first this one is same as this one. Now let us say this one, so we can calculate for this carbon, so we'll have carbon, this side 1 alkyl group, so 1 electron, this side we have hydrogen, so 2 electron. and this side we have double bond, so 2 electrons. So formal charge is 4 minus 5, that is minus 1, same as oxidation state. Now let us say this case, if I have carbon, so this is this side, so this carbon is equivalent as this carbon, and this carbon is equivalent as this carbon, so RH, this carbon is basically equivalent to this kind of carbon. So we can already say this carbon is same as this kind of carbon, oxidation number is 0, and this carbon is basically equivalent to this carbon, that is oxidation number of -1. So you see, lowest possible oxidation number of in case of alkane, so this is alkane, is -4, and while in case of alkene this is -2. So we have already said, if I have alkane, in this case carbon has a oxidation state of -4, and if I have this alkene, carbon has a oxidation state of -2. So we can say alkane, basically more alkane, lowest possible oxidation state in alkane is -4, while the original alkene is -2. So we can say alkenes are oxidized relative to alkanes. So higher oxidation number, this is more oxidized, so alkene is basically more oxidized because it has higher oxidation number, that is -2 is higher than -4, so this is higher oxidation number. So we can say this is highly oxidized. So alkenes are oxidized relative to alkanes. So let us say some more about oxidation number in case of alkyne. Idea is same. So if I have terminal alkyne, this kind of alkyne, both side we have hydrogen. So let us say we have this carbon. If I dissociate this bond, so 2 electron, dissociate this bond, so we'll have 3 electron. Now we can calculate formal charge. This is 4 minus 5, that is -1. So oxidation state in this case is equals to -1. Now let us say this case, this carbon is same as this carbon, that we have already calculated. Now let us consider this carbon. So we have this side alkyl group. The alkyl group is basically carbon. Now this side we have 3. So formal charge in this case is basically 4 minus 4, that is 0. So oxidation state is also 0 in this case. Now let us say this carbon is equivalent to this carbon, so this is 0, and this carbon is again equivalent to this carbon. So in this case this carbon will have 0 oxidation state, and this is also 0 oxidation state. So let us discuss some more common functional groups. Let us say alcohol. So alcohol, you can know basically alcohol can be primary alcohol, secondary alcohol, or tertiary alcohol. So let us say first consider a primary alcohol and this carbon. So if I see this carbon has 2 hydrogen. So 2 hydrogen will give 2 electron. Now this side we have oxygen, so no electron will come to the carbon, all these electrons will go to the oxygen. And this side this carbon is attached to a carbon, so we will have 1 electron. So calculate the formal charge. So this is 4 minus 5, that is -1. So this is a primary alcohol. Now let us say secondary alcohol. This carbon is attached to only 1 hydrogen. This side we have oxygen. So no electron will come. Basically both electron will go to the oxygen. And this side we have 2 carbon. So this carbon is attached to 2 carbon. So I will have 1 electron. So formal charge in this case, that is same as oxidation state, 4 minus 4, and that is 0. Now next one. Now this is a case of tertiary alcohol. So this is attached to 3 carbon. So from all the side you will have 1 electron. So we have this side oxygen. Oxygen will not contribute to any one of the electron. So formal charge in this case basically 4 minus 3, that is 1. So oxidation state is plus 1. So you see primary alcohol will have a minus 1, secondary alcohol will 0, and tertiary alcohol will be plus 1. So once again, on the basis of oxidation state, we cannot define the functional groups. Same functional group alcohol can have many oxidation states. So we can say on oxidation state basis, we cannot define functional group. Now let us say in case of aldehyde and ketone. So let us say for this case, for this carbon, I am interested in this carbon. So this side we have oxygen, so no electron will come to the carbon because oxygen is more electronegative. This side we have hydrogen, and this side also we have hydrogen. So formal charge in this case is 4 minus 4, and that is 0. And now in this case we will have this, no electron will come from this side. This side will give 1 electron, and from this side we will have 2 electrons. So formal charge in this case is basically 4 minus 3, and that is plus 1. Oxidation state in this case is plus 1. Now let us say ketone. So aldehyde can have a functional group basically oxidation state of 0, or it can have a functional that is the oxidation state of plus 1. But let us say ketone. In case of ketone, I will have no electron from this side, 1 electron from this side, 1 electron from this side. So formal charge we can calculate, that is 4 minus 2, that is basically plus 2. So oxidation state in case of ketone is plus 2. Now let us say acid derivatives. I have acid, this is formic acid, so this side we will have no electron. This side also we will have no electron because oxygen is more electronegative. So we'll get only 1 electron from hydrogen side. Hydrogen is less electronegative, so formal charge in this case is 4 minus 2, and that is basically 2. Now let us say this is a case of another acid. So I will have from this side no electron will come, from this side no electron will come, from this side you will have 1 electron because alkyl group is basically carbon. So this is a homoatomic bond, so bond between homoatoms. So formal charge in this case is 4 minus 1, that is basically 3. So you see acid can have a function or oxidation state of plus 2, or it can have a oxidation state of plus 3. So now let us say oxidation level on an atom only depend upon groups attached to it. So what are the groups attached to it? On this oxidation states depend. So let us say in the first case I have this case. This carbon is attached to 4-sided carbon. So oxidation state is 0. You see, you will divide, this side you will have 1 electron. This side you have, so 4 minus 4, that is 0, and that is same as oxidation state. Now in this case if you see, you will have 1 electron, 1 electron. From this side you will have 2 electron. So oxidation state in this case again 4 minus 4, that is 0. So you see it depends upon what kind of groups are attached. So if I have a carbon, if I have 4 carbon attached, oxidation state is 0. If I have same thing, but if I have 4 hydrogen is attached, something like this, in this case oxidation state of carbon will be minus 4. So it depends what are the groups is attached. So let us say in this case this carbon will have 2 electron from this side, and this side 1. Hydrogen is less electronegative, carbon is more electronegative, so we will have 2 electron and 2 electrons. So we have, so basically 6. So oxidation state is 4 minus 6, and that is minus 2. So we have 2, 4, 6 electron to this carbon. So oxidation state is basically minus 2 in this case. So oxidation state depends upon what are the groups attached to the carbon, either hydrogen or alkyl group or oxygen or chlorine. It depends upon what are the groups attached to the carbon. Now in this case you see this carbon will have oxidation state of 0, but this carbon, so let us find for this carbon is 0. What is this carbon? So this carbon 3 electron, from this side it will have 2 electron, so this will have oxidation state of 4 minus 5, that is minus 1. So this carbon will have oxidation state of minus 1 because this is attached by a hydrogen and this carbon is attached by alkyl group, so it will have a oxidation state of 0. So it depends upon what kinds of groups are attached. Now in this case let us find out oxidation state of this carbon. So if I see this carbon, this side we have 1 electron, this side we have 1 electron because carbon is attached to the carbon. This side we will have 2 electron because this is attached to hydrogen. This side no electron, so formal charge or oxidation state in this case, this is equals to 4 minus 4, and that is basically equals to 0. Now this case, now you see in this case you have again carbon, oxygen, hydrogen and hydrogen, so we can calculate. So this side no electron, this side 2 electron, and from this side you have 2 electron, so oxidation state in this case is 4 minus 4, and that is basically equals to 0. So oxidation state is 0. Now let us do some problems. We have this carbon, so you have to find what is the oxidation state of this carbon, and you also find out oxidation state of this carbon. So let me write in a better way. Now this will be easy for you, you can try yourself. So we have to find for this carbon and we have to find for this carbon. So let us say first for this carbon. So this carbon, this side is attached to the carbon but double bond, so we'll have 2 electron. From this side this is attached to one carbon, so 1 electron, and this side again attached to one carbon, so we'll have 1 electron. So formal charge will be 0 because 4 electron we have, so oxidation state of this carbon is 0. Are you getting or not? So in this case oxidation state is 0. Now let us say for this carbon, if I do the same kind of exercise for this carbon, but we will have, this is chlorine, so no electron will come. This is again chlorine, no electron will come. This side carbon, so half of the electron. This side carbon, half of the electron. So oxidation state is 4 minus 2, that is plus 2. Now let us do this problem. I have to find what is the oxidation state of this carbon, and this carbon. Now let us do one by one. So for this carbon first, if I try to do this carbon first, I have carbon, this is attached this side to the carbon, so 1 electron. This side carbon, 1 electron. This side carbon and this side also carbon, so 1 electron. So oxidation state is 4 minus 4, that is 0. Now let us say this carbon. We have carbon attached but double bond, so 2 electron. Carbon attached, 1 electron. Carbon attached, 1 electron. So once again oxidation state is 4 minus 4, that is 0. Now for this case, so you see this side we have carbon, so 1 electron. This side we have carbon, 1 electron, but this side we have oxygen, so no electron will come. So in this case oxidation state is 4 minus 2, that is plus 2. Now let us say this problem, we have to find what is the oxidation state of this carbon and this carbon. So let us first do this carbon. This carbon is attached to carbon, so 1 electron. This side we have carbon, another electron. This side also we have carbon, another electron. This side also we have carbon, so we have one more electron. So formal charge is same as oxidation state, that is 4 minus 4, and that is 0. Now let us say for this carbon. This carbon is attached to 2 oxygen, so no electron will come. This side also we have oxygen, so no electron will come. This side we have carbon, so 1 electron will come. So formal charge is equals to 4 minus 1, that is plus 3. So oxidation state of this carbon is basically plus 3. Now let us say this problem. So we have to find oxidation state of this carbon, this one, and this carbon. Basically this carbon, let us say first, attached to one carbon, one electron. This side we have carbon but two electron because a double bond. This side we have sulfur, and sulfur is more electronegative than carbon, so no electron will come. So formal charge or oxidation state in this case is equals to 4 minus 3, that is plus 1. Now let us say this carbon, this side we have a double bond and this side we have a hydrogen. Is nothing is written, we have a hydrogen, so we have two double bonds, so two electron will come. This side we have hydrogen, so hydrogen is less electronegative than carbon, so two electron will come. And sulfur side more electronegative, no electron will come. So oxidation state in this case is 4 minus 4, and that is equals to 0. So let us do these problems again. Now let us say this case, this carbon, we have to find this carbon and this carbon. Let us first do this carbon. This carbon is attached to oxygen, no electron, attached to hydrogen, 2 electron, attached to carbon, 1 electron, attached to carbon, 1 electron. So oxidation state is 4 minus 4, that is 0. Now let us say this carbon. Basically I have 4 bond, a hydrogen is also here. So this carbon attached to 1 carbon, 2 carbon, 3 carbon, and this side we have hydrogen, so 2 electron. So oxidation state is 4 minus 5, that is minus 1. Now in this case, this carbon, so this carbon is attached to carbon and this side we have carbon, so 1 electron. Oxygen is more electronegative, so no electron, so we will have oxidation state, this is 4 minus 2, and that is plus 2 oxidation state. Now let us say this carbon first. So I have carbon, this side oxygen, no electron will come. This side we have a carbon, so only 1 electron will come. So oxidation state will be 4 minus 1, that is plus 3. Now let us say this carbon, so this side oxygen, no electron. This side carbon, 1 electron. This side hydrogen, 2 electron. So oxidation state will be 4 minus 3, that is plus 1. So this is about calculating the oxidation states. One important point you have to remember, you have to see the carbon and what are the atom this is attached to the carbon. If it is attached to the homoatoms, you have to divide the bond equally, that is if it is attached to the carbon, you have to divide the bond equally, and if it is attached to chlorine, oxygen, nitrogen, sulfur, then you have to divide one unequally, that is the less electronegative atom will get no electron and more electronegative will get both electrons. So let us say in case of carbon and hydrogen, carbon will get both electron. In case of carbon and chlorine, chlorine will get both of electron. In case of carbon and oxygen, oxygen will get both of the electron.